Hello friends, we are discussing about the diode clipping circuits. In this one, now I am going to discuss about the bias diode clippers, or you can say diode clipping circuits. So now let me take one example of positive bias. So positive bias diode. So in this one, I'm going to first of all draw the input waveforms. So this is a vertical axis, that is for amplitude, horizontal axis for time. Here I am just going to provide a sinusoidal input. So this signal, sinusoidal input signal, over here, this one is plus V or plus V peak, that highest one, and lowest one is minus V peak, and that upper to lower limit that we can consider, that is V peak to peak. We'll take some values afterwards. Just right now, just I am taking V input signal, and these are the notation. And now I'm going to draw that circuit. So first of all, let me take this. These are the wires. Somewhere I'm going to draw the components. So over here we are going to check the outputs. These are the output terminals. Across these two terminals we are going to check the outputs. Here is input available. Okay, so let me draw the remaining part. Extra I'm going to rub it out. Okay, so here this side is nothing but our sinusoidal input signal, that is I'm considering V in over here. This side, here one more component, let me consider this one is a resistance. I'm connecting R I or R1 or something you can write. This side I'm going to connect diode, and over here a bias supply. So let me draw that diode. This diode direction is very much important when you are working on the output waveform for the clipping circuit. You see, diode is from this side is anode and this side is cathode. Now I'm just going to provide the bias supply. So this one is a bias supply. So you see, this diode, it is given only D, so we consider as a ideal diode. This resistance available over here, we need to find V output, and this one is the V bias. So this side is positive and this side is negative. You consider this one is a positive out and this is negative out terminals. So positive, this side is positive, this side is positive, this side is negative, this side is negative. So this one is considered as a positive bias, positive bias diode, positive bias diode, positive bias diode. So this terminal, you see, this terminal positive, this one is also positive, this terminal negative, this is also negative. So consider this one is a positive bias. Suppose this one is negative and this is positive, that is a negative bias one. Don't worry about the direction of the diode. Okay, so now we will work upon the output voltage. What will be the output waveform for this one? So let me draw that one output voltage over here. For this one I am just aligning both the side input and output so that it will be easy to understand. This side is the time. We are considering here ideal diode. Okay, and from here let me take this line for positive half and understanding of positive and negative half. Okay, this one is first cycle, now this is for the second cycle. and whenever it is considered a positive bias, so you can take over here somewhere, like if I take this one is a V and this is a V positive peak. Okay, so let us draw that this is a positive V peak and this is V bias. I am just considering this V bias is less than positive peak. Now let us check what will happen to the diode when this output is need to be considered. So we are going to work for this positive half, and what will happen for this at the this output side. This diode is an ideal diode, so there is no threshold voltage, zero threshold voltage. It will be working. Now let us go with the positive half cycle. So whenever positive half cycle, this side current is moving. So this is where current is moving. So here we'll get more than zero supply, but already V bias is something is higher than zero. So over here, so this diode, for when this is zero, but this V bias is some positive voltage, what will happen? Diode will be forward bias or reverse bias. We can directly say that for the positive half cycle, for this condition, the diode, you see, for this condition, when this is zero and this some positive value, the diode is in reverse bias. So what will happen if the diode is in reverse bias? If you see, diode is not working over here. If you see, you can see, I can draw like this way. Diode is not working. So what will happen from here? From here, the current is supply is directly going this way, and it is at the output side. Okay, so whatever the input is there, that is nothing but the output. Okay, so we can write over here like it is zero, then it is gradually increasing. At one point what will happen, at one point it will be equal to V bias, but till then the diode cannot be a forward bias. So diode is in reverse bias up to V in equal to V bias. This is first condition. So you see what will be output here, diode is going to be reverse bias. So V input equal to V output. Over there, V input equal to V output till diode is in reverse bias. So that circuit is open. So whatever input we are going to get at the output side. So up to this, our diode is reverse bias. But at one point, V input equal to V bias. Okay, so it will trying to, this V input is trying to go above V bias. Now see what will happen. Now when this V input is trying to go above V bias, at that time this V input is trying to go above V bias. At that time this positive and this negative terminal of diode, this Vp is higher than this V negative Vn. At that time you can say Vp minus Vn is greater than 0. We can directly say this diode, this ideal diode, I can say ideal diode is in forward bias. So what will happen? This diode, this will be directly connected over here. At this point, in waveform you can see, at this point, this diode is going to get forward bias. That means it will be act as a short circuited. Forward bias means diode will act as a short circuited. This diode is going to act as a short circuited. Now when diode is short circuited, what will happen? You see, diode is short circuited, so at that time this whatever V bias voltage is there, it is going to appear at the output side. This whatever V bias voltage is there, that is going to appear at the output side. So we can directly write it that V bias equal to V out. Whenever this forward bias diode is in forward bias. So at that time we can draw like this way. At this point, when diode is in forward bias, our output is straight. Now what will happen at one point, if I draw like this way, at one point, once again at this point, somewhere we bias over here, somewhere at this point, once again this V input is less than, trying to go less than V bias, and at that time once again this D will be reverse bias. So when this D is reverse bias, what will happen? You see, when this D is reverse bias, that will act as an open circuited. Once again we know that our whatever our V input, it is going to appear at the output side. So once again this will follow, input will follow, output will follow the input. So you see, up to whenever this one is increasing, whenever this input is increasing from this point, at that time only the diode is going to get in forward bias. Otherwise for this all the values, diode is in reverse bias. So whenever diode is in reverse bias, we'll never able to get the flat surface, flat output voltage. So this will V input is directly available over here. The V bias effect will not there until the diode is in forward bias. So here what will happen, this one V output will follow the input. Once again over here at V bias voltage level, this part will be flat at this point, and whenever it is going down V bias, V input is going down, once again the diode is in reverse bias and will get the V input equal to output. So over here this positive bias supply we have provided, and that is why we are getting this positive portion of the voltage is clipped. That is, according to us, we can decide how much voltage part of positive cycle, how much voltage part of the positive cycle that we want to clip, that is decided by us. So here is the understanding of positive bias diode clipping circuit. For this one you can take a value, like suppose you want to take a value of suppose this VP is 10 volt or 20 volt or 30 volt, anything. Suppose I am taking 15 volt, this one is minus 15 volt. Somewhere I take this bias equal to 5 volt, this one I am considering bias equal to 5 volt. So over here at 5 volt, this one is clipped, over here is minus 15 volt. So that value can be given, this one is a 5 volt. So and V in is given like V peak to peak equal to 30 watt. Okay, so upper side plus 15 volt and below side minus 15 watt. Likewise this can be also given. So that can be converted into example. If you understood this theory, you can easily able to calculate the example related to positive bias diode clipping circuit. Now in upcoming example we are going to check for the negative bias diode clipping circuits. Thank you very much.